Question number 31. Is the Earth a magnet? Since we have mentioned electromagnetic phenomena in the connection with the formation of the solar system, it would seem that the bodies of that system have magnetic properties. Could it be, then, that the Earth is a magnet? Indeed, scholars have been puzzling over the matter for centuries. The first person we know of to describe the property of some substances to attract iron was the Greek mathematician Thales. That's Thales, Thales, born in the year 636 and died in the year 546. He made these observations in the year 550. He described it in connection with a piece of rock found near the city of Magnesia in Asia Minor, from which the word magnet was derived. Magnets remained merely a curiosity until the Chinese discovered that magnetized needles invariably oriented themselves, if given a chance, in the north-south direction. Later that year, or better still, later that century, in 1180, the English scholar Alexander Neckam, born in 1157 and died in 1217, mentioned such a magnetic compass. It was eventually used to guide ships over the ocean and led to the great European age of exploration beginning in about 1420. In the year 1269, a French scholar, Petrus Peregrinus, born in the year 1240, was the first to study magnets systematically. He found, among other things, that every single magnet has two poles with opposite magnetic properties, usually referred to as the North Magnetic Pole and the South Magnetic Pole. The North Pole of one magnet attracts the South Pole of another, though two North Poles or two South Poles repel each other. But why would a magnet's North Pole point to the north of the Earth? Was the Earth itself a huge magnet? This possibility was investigated by an English scientist, William Gilbert, born in 1544 and died in 1603, who shaped a lodestone, the magnetic substance Thales had first studied, into a sphere. That's a lodestone, Lodeston. In 1600, he published a book in which he described the way a magnetic compass acted in the neighborhood of that magnetized sphere and showed that it acted just as it does in connection with the Earth. It then seemed that the Earth must be a magnet. But why? The possibility was that there might still be a huge piece of magnetized substance at the Earth's center, pointing north and south. And once people began to speculate that the Earth might have an iron core, that seemed to be the answer. In the year 1895, however, Pierre Curie, yes, the French scientist, discovered that iron lost its magnetism at temperatures over 760 degrees Celsius. For the Americans watching, that's equal to 1,400 degrees Fahrenheit. And since it is quite likely that Earth's core is well over that figure, it is obvious that the core is not a magnet in the ordinary sense. However, hot liquid iron will still conduct an electric current, and if the iron swirls, the turning current would create a magnetic field, Earth could then be not an ordinary magnet, but an electromagnet. In 1939, the German-American geophysicist Walter Morris Elsasser, born in the year 1904 and still alive during the writing of this book, suggested that Earth's rotation could cause swirls in the core that would produce a magnetic field. For the people wondering about the spelling of this particular scientist, it goes like this: Walter Morris Elsasser, Elsasser, with the 2 dots on the letter A. Although this is a widely accepted thought now, problems remain. The Earth's north and south magnetic poles are not located at the geographic poles, but about 1,600 kilometers away in each case. For the people wondering, that equals 1,000 miles. If a line is drawn from the Earth's north magnetic pole to its south magnetic pole through the body of the planet, it does not pass through the center of the Earth. What's more, the magnetic poles drift apart slowly, and the magnetic field grows more or less intense with time. There are times, in fact, when the magnetic field drops to zero, then reverses and grows in intensity again. There is still much we don't know about the detailed mechanics of Earth's magnetic field.